showed a laser show, which is consisting of these 6 projectors behind us. These 6 projectors are made by Con. They're each putting out about 1.2, 1.3 watts, something like that RGB, and we were operating them at full power. Now, because of the dimensions of this trade show booth, we're really very close to the audience, only about 5 meters distance to the audience, which is incredibly close, especially for a beam show. So now, you saw the beam show. I didn't tell you anything about I didn't tell you, hey, watch this thing. I didn't kind of prime you in any way. And so what I'd like to do is I'd like to ask you what your reaction to the beam show was, if you saw anything different, if you noticed anything different.
No, the only thing I noticed is I've seen a lot of laser shows in my life, and it was very noticeable. It was very pleasant to view. Right. I've seen a lot of booths here where I just looked at it like this.
It's like a
little bit bright, and this was really pleasant to look at. And I know a little bit about lasers, so I knew you had done something with a different heads. So. Sure. But it's very pleasant to watch from a close distance.
What would you say, Alberto?
Well, I consider the laser is a little bit fade or blur the lower part of the show.
Sure.
Of course, this is I don't know if it's a software or hardware modification. I think it's a hardware modification. Looks like it goes off of focus. But of course, in this case, you don't have any disturb to your eyes. It means that you don't get blinded by the laser.
And after it.
And after image, and you don't even have the effect of close your eyes when the laser passes through your eyes. Of course, when the laser goes up to your head, you still see the sharpness of the beam. But when it goes down, it's looks much safer and of course less disturbing than usual.
Well, that's right. It's what happens is this. I wrote an article for the Laserists magazine many years ago. The title of my article was Making Shows Safe and Effective. And as laserists, that's what we all want. We all want safety, but we also don't want to give up the effectiveness of the show. The conclusion of my article, and also the conclusion of John O'Hagan's thesis on audience scanning, is that the only way to get safety is to increase the divergence of the beam, basically to make the beam bigger. But the problem is that, as a laserist, making the beam bigger goes against every bone in your body. The reason why you're using a laser in the first place is because you want a nice tight beam. The laser beam, when it goes through the air, I call it cuts like a knife. It's just cutting, like literally just cutting the air. And what you can see with the fog is, I call it marbling. You see this kind of swirling effect, and you don't get that with a diverged beam.
We already use some tools, for instance, in Pangolin, where we reduce the brightness when we work on audience, especially with audience that can be affected more by the light of laser, like children, the amusement parks and stuff. So we put the area zones where the power drops down to 30% or less. But of course, this tool, I think, is even a step forward to this.
Yes, what you're talking about is the beam attenuation map.
Yeah, because beam attenuation map can also affect your white balance when you dim it to very low levels.
Yes.
With this show, I didn't notice any white balance changes at all. It was just very pleasant to shed the field.
Yes, it's because we're operating them at full power. No beam attenuation map on this.
Can I put a question now?
Okay, sure.
How does it work?
Okay, good.
We don't know, really.
That's a good question.
We're not paid.
And I'm going to reveal the answer now. What we have here is a special lens. And in the top portion of the lens, there is no change of the beam whatsoever. And in the bottom part of the lens, there is an increased divergence. Now, even though this lens has only 2 distinct areas, low divergence and high divergence, the beam is not infinitely small. And so as the laser beam crosses what I call the split between this, the beam actually will go through a transformation, so you don't really perceive, when you're watching this show, you don't really perceive this hard delineation. And so it makes, so even though it looks like a hard, you feel your fingernail, it's a very big step there, you don't really perceive that in the show. And So now what this does,
Glasses old people use.
it's kind of
with the lower part.
it's kind of like that, but this is a negative lens. The lens that you use in bifocals is positive lens. Yeah, so what we do is we use a negative lens, so it's always diverging the beam. It's always making the beam safer from any distance from the projector. And so what we have a series of this lens. Some of them that only increases the divergence a little bit, and some that increase the divergence a lot. On these lower projectors here, we're really just increasing the divergence quite a bit. We have a 200 millimeter focal length on that lens, which is only about, you guys know the metric system better than I do, 20, 30, something like this. Something like this. So yeah, the focal length on that lens is really very strong because 5 meters to the audience, so we've got to make it safe in a hurry. Well, great. Well, thanks, guys. Thank you. Yeah.
Thank you, Bill.
Sure. Thank you.